when a number of coplanar forces acts on a particle and the resultant of the particle is 0, then the algebraic sum of all the forces acting along the x direction must be 0. See students, I am telling the number of forces acting on a coplanar, the number of coplanar forces. Coplanar means which lies in one plane only. One plane means it will have two dimensions, that is x and y, or y and z, or z and x. We will have only two coordinates. If I consider only x axis and y axis, the number of forces are acting on a particle. So I am taking one. See students, I am taking one plane. I am taking a plane here, students. This is the plane I have taken. This is the plane I have taken, and this is the point. So plane and the point. Okay, students. Now what happened? You see, some number of forces are acting. The number of forces are acting, like first force F1, second force F2, third force F3, F4, and like so many forces are acting. Some n number of forces are acting and keeps the particle in equilibrium, and the particle is at rest. Its acceleration is 0. Then the vector sum of all the forces, it is like all these forces are acting in xy plane only, So this is x axis and this is y axis, If you divide every force into components, then the algebraic sum of all the forces acting along x axis must be 0, and the algebraic sum of the vector sum of all the forces. So vector sum of all the forces acting on the particle along y-axis must be 0. Okay, students. So we can write like that. So sigma fx is equal to 0 and sigma fy is equal to 0. And the next situation, the next point you see, students. So what is the next point? If some number of forces are acting, if some number of coplanar forces acting on a particle and the resultant is not equal to 0. Some number of coplanar forces are acting and the resultant force is not equal to 0. So then the resultant force can be written as, so since it is lying in the xy plane, we can write F bar is equal to Fx into I cap, and you can also write Fy into J cap. You can write like this. Okay, students, and we can write its magnitude also. So that is called modulus of F bar. So we can write its magnitude, that is called modulus of F bar. Modulus of F bar is equal to F, that F is equal to so Fx squared plus Fy squared we will write. So means I coefficient square plus J coefficient square we will write, And here Fx is equal to, so some number of forces are there, we are telling our students. So then Fx can be written as F1 into x plus second force x component plus third force x component plus so on. What you write, my dear students? So nth component x component Fx, and similarly the resultant force along the y-axis Fy is equal to, so F1y plus F2y plus what you write, students? F3y plus so on Fny. So like all these forces, so that Fx, how do we get, means like this. Okay, students, and Fy will be like this. So means we are writing all the components here. Okay, students. Now next point. So See students, some n number of coplanar forces. N number of coplanar forces are acting in this situation. So n number of what students? N number of coplanar forces. N number of coplanar forces acting on a particle. N number of coplanar forces acting on a particle, and its resultant is not equal to 0, and its resultant is not equal to 0. So the resultant force, if you write the net force or the resultant force, it is not equal to 0. So we have n number of coplanar forces acting on a particle and its resultant force is not equal to 0, then that resultant force can be written as F bar equal to Fx into I cap plus Fy into J cap. And here this F bar magnitude, if you want, write the I coefficient square Fx square and plus J coefficient square Fy square you will write. And you want to write the components. Then F1 Fx is equal to, how do I get the components? See, Fx is equal to, so F1x its component and make it, so simply Fx you write it. So since components are scalar, you need not to put any arrow mark. So Fx is equal to F1x, F2x, F3x like Fnx, and you will get like this. Now, and so next one, I want to teach you what is a Lami's theorem and its statement, and after that we'll go for a tangent law. So to understand the tangent law well, we should know a Lami's theorem clearly. So now see what is a Lami's theorem. Now next one, so next, this Lami's theorem statement and application is very important for understanding the physics and vectors, my dear students. So please listen carefully. What is Lami's theorem? So if three forces or three vectors acts at a point, see students, three forces, because force is a vector, I can call three vectors, or three forces I can call. Now three forces acts at a point. So this is one vector. Okay students, let this vector be A bar, and this is another vector, it's a B bar, and this is another vector. So what is this students? C bar. So we have three vectors here. So what are those students? So A bar, B bar, C bar. These three vectors we can consider as three forces. Three forces acts on a particle simultaneously and keeps the particle at rest. Three forces acts on a particle or on a point and keeps the particle at rest. Okay. And angle between, so B and C, angle between B and C is alpha, we consider. Okay, and angle between A and C you consider beta, and consider the angle between A and B as gamma. Okay students, so now we are considering the angles alpha, beta, gamma. Okay, then according to Lami's theorem statement, so the ratio of, so what is the Lami's theorem statement? You see students, the ratio of sine. Okay, then three forces are acting at a point and keeps the point at rest. We got it. Okay, so then Lami's theorem, according to the Lami's theorem statement, what do we get? You see here, students. Then so the ratio of sine angle of the respective side. So I am writing the statement here. You see, students, ratio of sine angle to the respective side. The ratio of sine angle to the respective side. So ratio of sine angle to the respective side to the length of side, to the length of side is constant. So this is the Lami's theorem statement. So if three forces or three vectors acts at a point simultaneously and keeps the particle in equilibrium, okay, and let those three vectors are A bar, B bar and C bar. The angle between B and C is alpha. Angle between, so next C and A, okay, that is called gamma, and angle between A and B is called beta. Then according to the Lami's theorem statement, what is that? You see, my dear students, it is the ratio of sine angle to the respective side. The ratio of sine angle to the respective side by the length of the side always remains constant. So what is that? See, the ratio of the sine angle containing the side. So means we can write like this, see, my dear students. That is, so ratio of sine angle. This is called sine alpha. So I am writing sine alpha by, so sine alpha by the ratio of sine angle to the representing side, to the respective side, or you can call representing side. So representing side. So that is sine alpha by A. So this alpha is the representing side is A bar, sine alpha by A, and here what will you write, students? Sine beta by B, and here what will you write, students? Sine gamma by C. This ratio always remains constant, or so otherwise in some books the same statement they will give you like this, see. So in some other books they will give you like this, see. So each force is proportional to the, okay, or another definition, each force, if you consider these are the forces, each force is proportional. Each force is proportional to the, each force is proportional to the angle between. So each force or each vector we can call here. Here force is a vector, you know. So each force or each vector is proportional to the angle between the other two vectors. So each force is proportional to the angle between other two forces or vectors. You can write the statement like this also. Each force is proportional to the angle between other two forces. Means if A bar is a force, this A bar is directly proportional to, I'll write like this, see. This A bar, this is the force, and this is directly proportional to angle between other two vectors. So angle between other two vectors means what should I write? Each force is proportional to the sine angle. Each force is proportional to the sine angle. So sine angle between other two vectors you can write, students. So means A is directly proportional to sine alpha. Means you can write A by sine alpha constant. So A by sine alpha, A is directly proportional to sine alpha, and B is directly proportional to so what will you get, students? B is directly proportional to sine beta, B is directly proportional to sine beta, and C is also directly proportional to sine gamma. And if you write the ratio A by sine alpha, you will get one constant. So you can write A by sine alpha, you can write, or you can write sine alpha by A. You will get one constant, and that constant is same as that of sine beta by B, you can write, and that is also is equal to the sine gamma by C also you can write. Okay, students, this is the Lami's theorem statement, and in this Lami's theorem statement, and remember my dear students, so this is the Lami's theorem statement. Again we can discuss Lami's theorem very clearly, you just remember, and these three forces, and now these so here you see, students, whenever three forces or three vectors acts at a point and keeps the particle at rest, then those three vectors can be represented by three adjacent sides of a triangle taken in the same order. Then see, students, these three vectors, here the three forces acting on a point and keeping the particle at rest. Then these three forces I can represent along the three sides of a triangle taken in the same order. So means, see, students, I did not change the magnitude. That is called A bar, and I did not change the direction also. Okay, students, this is A bar, and now this is the another vector B bar. See, its direction I did not change, I just have taken like this. Okay, A bar vector one side of the triangle, B bar vector another side of the triangle. Okay, students, and next one is C bar. This is the another one which is called C bar. See, students, C bar, this is the C bar vector. I did not change its direction or I did not change its magnitude. So then whenever three vectors acts at a point and keeps the particle at rest, those three vectors can be represented by the three adjacent sides of the triangle taken in the same order I am telling you. So that's why order you see. So AB is the side represented by the first vector, and BC is the side represented by the second vector, that is called B bar, and CA is the side represented by the third vector. So then, and we know, you see, students, and now this is a bar vector, this is a bar vector direction, this is a bar vector direction. So angle between, so A bar and B bar, angle between A bar vector and B bar vector. So angle between A and B, the angle between A and B is gamma. So angle between A and B is gamma. So we can take this as gamma. Okay students, I think already you have learned about the angles, parallelogram of vectors, the fundamentals you have learned it. So what will happen you see students, so the angle between, this is the A bar vector, this is the A bar vector and this is the B bar vector. If you extend this one and this angle is same as that of this angle. Okay, so if this is gamma, this will be also gamma. Okay, so this angle is called gamma, and if I extended, this is the C bar direction, this is the C bar magnitude and its direction. I can keep anywhere here. Direction I did not change. The same direction I kept. So now the angle between C bar and A bar, the angle between C bar and A bar, how much angle I have taken? You see here students, C and A, I took beta, so I can take this angle is beta. And I can also take, so next one, extend this, the angle between, this is which vector, C bar and this is A bar, then this is gamma. Okay, so here our triangle is what you see students, triangle, what is a triangle? The triangle is ABC, triangle ABC we have here, and AB is one side, BC is another side, and CA is the third side we have. We have the three sides here, okay students? And this angle is alpha. We know the rest of this angle is 180 degrees minus alpha. Okay students? So 180 minus alpha, and this is gamma, you know, it is a straight line angle, 180 degrees. So the rest of this angle is 180 degrees minus gamma, and this angle is, so 180 degrees minus beta. Okay students, so we got the angles like this. Now, so in the Lami's means the same I can represent like this also. Okay, if three forces acts at a point and keeps at the particle, then those three forces can be represented along the three adjacent sides of a triangle like this, and angles also I have taken. Then, so then what we can write here, you see students, then we can write like this C. Then this A bar vector, its magnitude is A. Then the ratio, magnitude of the vector representing along AB, A by AB, this ratio is same as that of magnitude of the vector. B bar is a vector, its magnitude is B. It is representing along the side B bar by BC, which is same as that of, so C by AC. This is also, so what is this? Constant. So this is also a constant, we can write like that. Or the same you can write it as, what is that? You see students, the same you can write it as A by sine alpha. So sine alpha is equal to B by sine beta is equal to, so you can write C by sine gamma. So C by sine gamma is equal to is equal to constant also, we can write it, is equal to constant. That is also called Lami's theorem. Lami's theorem can be written like this or can be written like this. The ratio of, or the same, you just reverse it, or the same if you reverse it, you will get the statement like this, students. So what do we get, you see students? So what do we get? Sine alpha by A. So the same I can write, sine alpha by A is equal to, so what I write? Sine beta by B is equal to, what I write students? Sine gamma by C, that is equal to constant. I can write it like this also. Or, so we know that this alpha I can write it as, so sine theta can be written as sine 180 degrees minus alpha, sine 180 minus alpha, and sine beta can be written as sine 180 degrees minus beta, and this I can write it as sine 180 degrees minus gamma, and that is equal to constant. I can write like this also, because sine 180 minus alpha, it is in the second quadrant, 180 minus alpha becomes sin alpha only. Means this is also same. Means a by sin alpha, b by sin beta, c by sin gamma is equal to constant we will get. Okay students, now I will go for tangent law. So application of the Lami's theorem will go for the tangent law, and these formulas we will use while doing the numericals. So please remember well, my dear students. Okay, so the next one is tangent law. So the tangent law is the application of Lami's theorem. It's very easy, my dear students. Consider a simple pendulum. Consider a pendulum. Consider a pendulum which is pulled aside. Which is pulled aside by making an angle theta with the vertical. Consider a pendulum, so which is pulled aside by making an angle theta with the vertical. Okay students, so that is see what I am doing here. So I am taking a pendulum, okay, and this is the heavy mass that is called bar suspended here, and now you pulled this one with some horizontal force. So I have pulled that with some horizontal force. Okay students, so it is making an angle theta with the vertical. This is called the vertical. Okay students, the total length, this is the total length, this is the total length L, okay, and this is the horizontal force applied, this is the horizontal force applied, and this is the tension in the string, and this is the weight. So weight we are writing mg, and applied horizontal force we are writing F, and tension we are writing as T. So here see how many forces are acting, you see students. So horizontal force, so this will have some mass, it has mass means it has weight. So this bar will have some mass M, it has mass means it has weight, that is called mg. It is always vertically downward direction. So the same diagram I will draw here, you see students. Now here how many forces are acting? 3 forces are acting and keeps the particle at rest. So then so what is that? Sine rule. That is we can call it as a sine rule or by Lami's theorem. So if this is theta and if I extend this line, this angle also theta. So this angle, this is theta, this is also theta, because alternate interior angles are equal. Alternate interior angles are equal. So means this is theta. Now you see students. So I will go for that only the forces acting on it I will write here. So this is the bob, you know. This is the weight we know, this is called mg, that is called weight acting vertically downward direction. So weight is acting vertically downward direction, horizontal force acting in this direction, and the tension acting in this direction. This is the tension force. Okay students, now see students, this angle is 90 degrees. This is 90 degrees and this is, what do you know students, this is theta, you know. Okay students, you know this is theta, and this is okay, means this full angle, this is 90, this is 90 we know, and this is theta, you know. So we know that this is theta, then this full angle will become 90 plus theta. Okay, and this is this angle is theta, means this angle will become 180 degrees minus theta. Did you understand the angle students? Write very slow and clearly, draw from a particular point. So from the particular point you draw the angles very clearly. So now I can write like this, you see students. Then three forces are acting on this point and keeping the particle at rest. Then by the Lami's theorem I can write like this, see. So each force is proportional to sine of the angle between other two forces. If this is F and this angle is called alpha, F by sine alpha means F by sine of 180 minus theta. Sine 180 degrees minus theta is same as that of. So this is called what students? Weight. So W by, so what will write? W by sine 90 plus theta. W by sine 90 degrees plus theta, which is same as that of tension T. So what will write students? T by, so what can you write students? Sine 90 degrees you can write it. Did you understand the Lami's theorem or the sine rule students? See, each force is proportional to the sine of the angle between other two forces. Then F is directly proportional to sine 180 degrees minus theta. This ratio is same as that of tension force. This force, opposite angle 90, T by sine 90 degrees, weight, opposite angle sine 90 plus theta. So this is always constant. So or three forces acts on a particle and keeps the particle at rest. Okay, then we can write the same like this also. See students. So let us consider that this bob is displaced by some distance x. This bob is displaced by some distance x, horizontal distance, because we applied the force. With this force we pull it to here. So means this is the horizontal displacement. This total length, how much you know, my dear students? This total length is L. Okay, means this length is L. This length also L only. Okay, because see students. So when it has gone to here, the length will be same from here to here. See, in my hand from here to here length and here to here length is same only. This length also L, and this is the x distance you know, and this angle is 90 degrees we know. This angle is 90 degrees. Then this you will get root over. This is the hypotenuse, and this is one side. You will get root over L square minus x square. So this length is root over L square minus x square. This length is x, and this length is L you know. So then, so T by force by that side's ratio. The force acting, this is the triangle you see. In this triangle, this is the force acting F. This is the force acting. Then you can write F by x ratio is same as that of the force acting along his weight, that is W by, you can write W by, so this one, what is the length acting along that side? Root over L square minus x square. So W by, so what do you write students? Root over L square minus x square, and that is equal to, so tension force acting along the length. So T by L is equal to, what can you write my dear students? Is equal to constant you can write. So you can write like this also. When a particle is in equilibrium and three forces are acting, three forces can be represented along the three sides. Then the ratio of a force, the ratio of the side of the triangle to the length of the triangle. So force and its length F by x, it is also constant. And now I can use this rule. So I am using that rule. You see students, that rule what I am getting. So what I am getting, you see students, if I take F by sine 180 minus theta, F by sine 180 degrees minus theta can be written as sine 180 degrees minus theta can be written as f by sine theta and w by sine 90 plus theta. So odd multiple of 90, sine will become cos, you know. So w by cos theta, which is same as that of t by 1. So then we can write like this, see, then w is equal to, take these two quantities only, then f by sine theta, f by sine theta is equal to w by, what do you write students, cos theta you write it, then f is equal to, so sine theta by cross multiplication you just do it, sine theta by cos theta into w, so means then f is equal to sine theta by cos theta can be written as what students, tan theta into w you can write it. So then applied force F is equal to W means mg, you can write mg into tan theta. So F is equal to mg into tan theta, or you can equate any q in this one and you get the unknown quantity. So equate W, if you know weight, you know the tension and this angle 90 and you can get this theta value. So depending on the number of variables, go for anything, you will get another one. Okay students, so means applied force F is equal to mg tan theta or W into tan theta you can write, or you can go in another method also, you see students, that is components method we will go. So this is called mg, you know students, and we know this is the tension, you know students, and we know this is the tension, you know students. Now this tension we are writing into two components. So this is angle theta, you know. So write this side as t cos theta and write this side. You write this side as what is this students? T sin theta. And since the particle is in equilibrium, it is in equilibrium, you know. Then F is equal to, it is in equilibrium means x components are balanced. Then F is equal to t into sin theta can be written. F is equal to t into sin theta and mg is balanced by t cos theta. So you can write, this is, see students, F is equal to t sin theta I have written. F is equal to t into, okay students, see tangent law formula we can derive from the component methods also. So that is, so the tangent law formula in components methods you see students. This is our pendulum suspended from a rigid support, and you pull this aside, pull it aside, so that it is making an angle. So we are pulling by applying a force F. So this is the applied force. So it is making an angle theta, and this bob has some mass. So it has mass means it has what do you know students, weight. So this is called mg. So weight we are denominator W. Tension in the string is T. Now we dissolve this into two components. So this is the tension in the string. If this is theta, this is also theta. This side we write it as t cos theta. This side we write it as t sin theta. So I just resolve the tension into two components. So adjacent side cos theta, opposite side sin theta I have written. So now you know that. So since this is at rest, means forces along x component of forces along x axis. So the forces along x axis are balanced. Component of forces along x-axis are balanced. Components of forces along x-axis are balanced. So F is balanced by T sin theta. The horizontal force is balanced by T into sin theta. Equation number 1. And T cos theta is balanced by the weight. So mg is equal to T cos theta. Components along a vertical direction. So see students, vertical direction. So vertical direction we are writing the forces. So T cos theta is equal to mg. So means you are writing. So mg is balanced by T cos theta. So mg is equal to T into cos theta. Equation number 2. Now dividing equation 2 with equation 1. So divide equation 2 with equation 1. Then what will you get, you see students? F by mg. So F by mg is equal to T sin theta by, so what is this? T cos theta. And T gets cancelled. Sin theta by cos theta, we can write it as tan theta. So means what do we got it, see students? So we have got it. Okay students. So then F by so we can write like this, students. F by mg is equal to tan theta. Then F is equal to mg into tan of theta. So means applied force is equal to mg into tan theta, you can write it. Okay students.